Hi guys. Today we're moving on to section 4.4, the last section of the chapter. Yesterday we talked about side, 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 and side, angle, side, and now today we're going to go through the same process, but now we're going to add two more different ways of proving triangles congruent. So our learning target for today is I can prove that two triangles are congruent using ASA and AAS. All right, so the first one is angle, side, angle, angle, side, angle, ASA. This theorem states that if two angles and the included side are congruent to two angles and the included side of another triangle, then the triangles are congruent. All right. So here's what this looks like. If I have a triangle here and a triangle here, this one we'll call L, M, N, and this one we'll call S, R, T. So here's what this will look like. We'll have two angles of one triangle. So we'll talk about angle L and angle N are going to be congruent to two angles over here. So we'll talk about angle L being congruent to angle S, angle N being congruent to angle T, and the included side. So the side that connects those two angles. So this one right here is congruent to the side, the included side that connects those two angles. All right. So 1, 2, 3, 1, 2, 3, two angles, side in the middle, two angles, side in the middle. These are congruent by angle, side, angle. Now we can write a congruent statement stating that triangle, I'm going to say LMN, is congruent to triangle. Now I have to put it in the correct order. L has one arc mark, so it corresponds to the one arc mark over here. S. M is the one with no marks, so the one with no marks over here is R. And finally, N here. All right, so that's the angle, side, angle congruence theorem. Angle, angle, side is going to be a little different. This one states that if two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the triangles are congruent. So what does this look like? Well, I'm going to draw a triangle here. We'll draw an obtuse triangle. We'll draw an obtuse triangle here. We'll call this one, I don't know, L, M, C. and WJD. So this case, we're going to have two angles on one. So we'll say angle L and angle C. Those are going to be congruent to two angles over here. So I'll say angle J is congruent to angle L. Angle W is congruent to angle C. Now I want the non-included side. So this could be two different sides because the side that is included on this triangle is LC. The side that is included on this triangle is WJ. So it cannot be that one. Otherwise, it would be angle side angle. So it's going to be, I don't know, we'll say this one here, angle CM is congruent to WD. This is angle, side. Two angles in one triangle, a side that is not in between those two angles. Two angles over here, the side that is not in between those two angles. So, triangle, okay? L, M, C, remember the first order can be whatever you want. Now we want to match it up. Angle L is congruent to angle J. Angle M is congruent to angle D. And angle C is congruent to angle W. All right, so that's the pattern there. So looking at example 1, they want to know, are these triangles congruent? If so, state what makes them congruent and write a congruent statement. So that's stating, that's this right here. So here's the process on part A. I want to match up. Remember 2 days ago we listed out all the things that are congruent? I'm not asking you to list it out, but I am going to ask you that you label these. So we have an angle here. I don't know what this angle was. I don't know, we'll say J. There's a hole in there. J, K, L. Okay. I know the angle J, so that's an angle, is congruent to angle Q over here, A. I have angle K on this is congruent to angle R here. And finally, KL is congruent to PR. So the tricky part with these ones is in both of the new theorems, we have two angles and a side. So we have to determine between the two which one it's going to be based on where the side is located. So two angles, I'm going to ask the question every time, is the side included between these two angles? No, the side is over here. So it's not included, which makes it angle, side. All right, let's take a look at part B. Oh, sorry. Now we need to write a congruent statement. So triangle, I'm going to go JKL is congruent to triangle. Well, J corresponded to Q. K corresponded to R. L corresponded to P. All right. So now part B, let's go through and label. We have angle K. Angle is congruent to N, another angle. Angle L is congruent to angle O. And then side LKS is congruent to side NO. These, to me, are the easiest to spot because they're all in an order. They almost spell it out for you. The side is smack dab in between the two angles. They all fall on one side. So that makes it angle, side, angle. And we can state that they're congruent by J, K, L is congruent to triangle. Well, J corresponds to M, K corresponds to N, and L corresponds to O. All right. Over here, we have angle K, an angle congruent to an angle Q. We have side KL and S congruent to side MQ. I'm just following the tick marks. I have another side. We have JL congruent to MN. So are angle side angle and angle side even an option? No, because I have two S's and an A. So here's all of our options. We have angle side angle side, which we learned today. Yesterday we did side, and side angle side. Okay, those are the only four ways. I know it's not this one or this one because I have two sides here, and these don't allow for two sides. It's not this because I don't have three. Now, a lot of us are going to say, okay, great, it's side, angle, side. But we have to ask that final question. In order for it to be side, angle, side, the angle has to be included. It has to be in between the two sides, included. Well, if I have this side here and this side here, is the angle marked here in between there? No. You saw me kind of do this motion. If the side and the side doesn't have a congruent mark on the angle in between, then it is not. So you can actually leave this as not congruent. All right, so let's go ahead and turn the page. Now, D and E, we're not going to talk about F today. D and E. Remember, we're going to start out with KJ is congruent to MN sides. We have angle K is congruent to angle M. Now, I didn't mention this before because I could easily come up with three pieces. When they only give you two, your next step is to look at the figure and figure out, is there anything I can add based on what I know? Well, the two things that we know are shared side, for when they share a side, they're connected by a full side, or vertical angles. Vertical angles are our bow tie. Okay, when we form a bow tie with triangles, we get vertical angles. Well, that's what's happening here. They're meeting at this point, and this is congruent to this. All right, oops, I'm going to put two because they're match up. So now I've just added another angle. So my options are angle, angle, side, angle, side, angle, side, 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 and side, angle, side. Well, we have two angles and a side, so I'm going to eliminate those. Is the side mentioned in between the two angles? In between the two angles, is the side right there? No. So it's around the corner, so it's an angle, angle, side. And now I can say that triangle JKL is congruent to triangle NML. Next one, we'll start with what we have. We have an angle A congruent to angle D. We have this 90 degrees right here, so that's an angle, but I don't have anything that it matches up with. They didn't put anything there. However, I know if this side is 90, this side is also 90 because they have to add up to 180. So I can add an angle there. Now, is there anything else that I can add? Well, I kind of already did this one when I mentioned this BC as a shared side. Since it's on both triangles, it's congruent to itself. So now I have an angle. And I have a side over here. Is the side in between the two angles on that shared or on that side there? No. So it's an angle, angle, side. And the congruent statement is triangle ABC is congruent to triangle DBC. All right. So example 2, and then we'll be done. Is triangle JKL congruent to MNL? JKL, MNO, excuse me. Are these two triangles congruent? Well, J congruent to M, K congruent to N, JK aside, MN aside. Is this spelling out one of our options? Yes, we have an angle, side, angle. So yes, our explanation or justification is just angle, side, angle. That is proof. Well, now is JKL congruent to PQR? So I'll do this in a different color. I have an angle congruent to an angle. I have an angle here congruent to this angle, and I have a side congruent to a side. Well, over here we have this pattern of angle, side, angle, all forming on this side JK. Is that the same thing that's happening over here? Okay, do I have an angle and am I mentioning the side in between? No. So if one spells out angle, side, angle, and the other spells out angle, angle, side, they don't match. So are these congruent? No. Okay, and that is about it. Please contact me if you have any questions on this lesson. Part of your assignment today will be working through this back page here.